Hello, geometry students. We're here in section 13-5, and this is the probabilities of independent and dependent events, and we do have some new vocabulary. And the new vocabulary is compound event. Okay, so there's going to be more than one event. Then we're also going to have independent events. We're also going to have dependent events. And we're going to have this concept called, or new vocabulary called, conditional probability. We're also going to look at something called a probability tree. So here's example number one. We're going to identify independent and dependent events. Okay, determine whether the event is independent or dependent, and we'll explain our reasoning. Okay, a die is rolled, and then a second die is rolled. Well, the outcome of the first die does not have an effect on the outcome of the second die. And that's the concept of independent. Okay, let's see how the book explains it. Okay, the two events are independent because the first roll in no way changes the probability of the second roll. Good. Example. Determine whether the event is independent or dependent. Explain your reasoning. A card selected from a deck of cards and not put back in. Okay, so once a card is taken out of the deck, then there's only going to be 51 cards in the deck. Right, so the chances that a second card is selected does get affected. So these two events are going to be dependent. Okay, so the events are dependent because the first card's removed and that cannot be selected again, and this affects the probability of the second draw because the sample space is reduced by one card from 52 cards down to 51 cards. Okay, here's going to check your progress. You can pause your video. Determine whether the event is independent or dependent. Explain your reasoning. A marble selected from a bag, it's not put back, then a second marble is selected. Well, that would be a dependent event. Okay, check your progress. A marble selected from a bag, then a card is selected from a deck of cards. Well, a marble being selected and a card being selected from a deck of cards, right? One is not going to affect the other, so these are independent events. Okay, probability of two independent events. If we have two independent events, then the probability of both events occurring, and written as probability of A and B, is the probability of the first event multiplied by the probability of the second event. So this little dot right here represents multiplication. So here's our example using this. So we have eating out. Michelle and Christina are going out to lunch. They put 5 green slips of paper and 6 red slips of paper into a bag. If a person draws a green slip, they will order a hamburger. If they draw a red slip, they order pizza. Okay, suppose Michelle draws a slip. Not liking the outcome, she puts it back and draws a second time. Okay, what's the probability that on each draw her slip is green? Okay, now since she put the slip back in, then these are independent events. So we can actually find the probability of the first and the second selection are both green. And so we can say that would be the probability of green and green. Or you can say it's probability of the green multiplied by the probability of green. Okay? Now, we know that the probability would be 5/11 because there are 5 green and 6 red. So the total of 11. 11 slips of paper, 5 of which are green. So you have 5/11 times 5/11, or 25/121. So the probability that on each draw her slips were green would be 25 over 121. Okay, go ahead and check your progress. You can pause your video if you like. So what's the probability that each draw she would draw a red marble? And there are 4 red, 6 green, and 5 yellow. Okay, and the answer ends up being 7.1%. Now how do we get that? Well, for the red marble to be drawn, that's only 4 red marbles out of a total of, looks like 15 marbles. 4 out of 15, because 4 plus 6 plus 5. Then if she puts it back in, her odds of picking a red marble again are also 4 out of 15. So we're going to take this and get 16 out of 225. And then in a calculator, you can take 16 and divide by 225. And when you do that, you get 0.0711. So this is approximately equal to 0.0711. And then to make this into a percentage, you just move it over 2 places. So that'd be 7.11%. But they only gave their answer to the nearest tenth. 7.1%. Okay, here's a probability of 2 dependent events. Okay, probability of 2 dependent events of both occurring is the product of the first. So we have A and B. So it's the probability of the first multiplied by the conditional probability. So this is how it's read. So it's the probability the first event occurs and the probability that the second event occurs after the first event has already occurred, and that's called a conditional probability. So the way you indicate that is the B with this little line here, and that A, and that's red, probability of B given A. So you're going to multiply the probability of A multiplied not just the probability of B, but the probability of B given A occurred. Let's see this in action. So, refer to example 2. Recall that there were 5 green slips of paper and 6 red slips. Suppose that Michelle draws a slip and does not put it back in. Now we're trying to figure out what's the probability that both draws were green slips. So again, we are doing, the probability of G and G. However, the slip's not going back in. So we can find this by taking the probability that the first one is green. So let's put that as the G1. How about that, right? And then we're going to multiply that by the probability that the second one is green, given, right, that the first one is green. Well, the probability that the first one is green, it's pretty straightforward. It was exactly what it was before, and that would be 5 out of 11. Now, if the green slip is not put back in, so this time it's not being put back in, so this slip right here, not put back in, then there is 1 less green one in there, so there's only 4 green ones left, and there's 1 less slip to pick from. So the probability that you pick a second green, given that the first one we picked was green and not put back in, would be 4/10. And it looks like this could reduce, right? And we can reduce again. And it looks like it's going to be 2/11. Let's see what they get as an answer. Okay, so the events are dependent. And we have 5/11 times 4/10, and that does reduce down to 2/11. So that's about 18%. Okay, check your progress. So here's your marbles: 4 red, 6 green, and 5 yellow. Go ahead and pause your video. What's the probability that both draw green marbles? Good. Now if you said 1/7, let's see how that is found. So the odds we're looking for is the chance that they picked a a green marble. Thought this was red marble like the last example. Let's see. Let's go back. No, let's just try to answer this and see if that they just made a mistake with the word. So green marble, you're going to have 6. Okay, we're going to have 6 out of the total. And how many marbles are there? There are 15. So the chance you actually pick a green marble the first time is 6/15. If you don't put it back in, there is 1 less green marble, and there's 1 less actual marble itself. So these can reduce by division of 5. And the 6 and the 14 reduce by division of 2. And then I guess the 3's do reduce. And there's your 1/7.